Hey there. This is just a real quick little bonus video to illustrate how you can think about one-sided limits graphically by looking at some animations that I have in Desmos. So we're going to be looking at a function like the one I've got drawn here for you. It's some function y equals f of x. We don't need its formula. And the question we're going to be talking about, questions, are what are the left and right-hand limits of that function as x approaches 0? Well, from the left and the right respectively. We'll start off looking at the left. So let's switch over to Desmos. Now you're looking at that same function in the Desmos window, okay? And we're going to take a look at the left-hand limit first. So I've got an input value marked down here, a number on the x-axis. Input values come from the horizontal axis. And I'm going to let that input value approach 0 from the left. From the left, because these numbers are less than 0, yeah? And they're less than 0, getting bigger. And now you can see in the picture the corresponding point on the graph, x comma f of x. And in particular, you can see the output value. And the main reason I wanted to make this animation is to emphasize that this limit question we're asking what is happening to this number on the y-axis, the output value, f of x, as we drive the input value towards our target, in this case from the left, from 0 to the left. So you can answer that question by watching the y-coordinate on the graph. But make sure you understand that it's that y-coordinate that we're asking what's happening to it. We're driving what's happening to the x-coordinate. So I like this animation for that reason. So if I just continue it, I let x get closer and closer to 0, it appears that output coordinate is getting closer and closer to the number -1. You can read the axes. All right, so the left-hand limit from this graph is -1. The right-hand limit is the exact same thing, except that we drive the input from values that are bigger than it, to the right of it. And you can see that the output coordinate on the y-axis, it's increasing. So that limit looks like it's getting, or that the y value is getting bigger, excuse me. And as x gets closer and closer to 0, that y value gets closer and closer to the value 2. You can see on the axes. All right, so the left-hand limit of this function is -1. The right-hand limit at 0 is 2. They're not equal, so there's no two-sided limit. The function's value itself is 1. So it doesn't equal either one of those one-sided limits. So this function is not continuous. It's not continuous from the left. It's not continuous from the right. Okay, just real quick for some eye candy. This whole animation thing was inspired by a nice conversation I had in my office hour today, so I had fun making these things. I wanted to share them. Here's the function sine of 1 over x. I can flash the formula to you if it's hard to imagine that. Sine of parentheses 1 over x. We've talked about this function in previous lectures. If we drive the input towards 0, you can see that the output doesn't behave very nicely. Right now it's getting bigger. Okay, I'm just watching the point on the y-axis, but now it's getting smaller. And it bottomed out pretty quickly, and now it's risen all the way to the top again. So it's going all the way bottom top, but faster and faster and faster. So there is no limit there. That output coordinate isn't getting close to something. It's just oscillating back and forth, back and forth, back and forth between -1. If we came from the other side, we'd see the same thing. Yeah. It's going back and forth, faster and faster and faster and faster and faster. So that's what all that red mess in the middle of that picture is. The graph is just sort of smashed up together. The computer can't draw it thin enough. If I turn this off, you can see a little bit better resolution, but even then, there's no amount of thinness that it's going to be able to draw that picture. But this animation kind of gives you the idea of what I mean. That limit doesn't exist. The y-coordinate doesn't approach anything. It bounces all over. Let's look at one more. This can illustrate what I mean by limits at infinity. If we let this input value approach -2 from the left, watching that y-coordinate, what's it doing? It's flying up to Never Never Land. It's going to infinity. So that's what I mean by an infinite limit. You can certainly watch the y-coordinate on the graph, but make sure you understand the limit is a statement about the output. It's about the output, a y-axis number. If we jump across here and let x go to 2 from the left, you can see that the limit is -infinity. Yeah, this function's not defined at 2. You can see the little open circle there, but I can let x approach 2. I'll start from the left. That's the side I'm on. And I can see, yeah, look, that output value is definitely approaching something. Look at that thing on the y-axis. It's not going anywhere. That's what it means for the limit to exist. That y-coordinate isn't going anywhere. Why did everything just disappear? The function's not defined at 2. So when the x input is 2, there is no output. So there's nothing to plot. But now, yeah, from the right, the closer we get to 2, I like this demonstration. The output, you can watch it on the y-axis. It's not changing very much. It's because we're approaching what its limit value is. And what is that limit value? Well, we'd have to zoom in. We can do it here. This video is over. It looks like that limit value is 6. Okay, so this was fun to make. I hope it is helpful for you to know what to look at when you're looking at limits on a graph. So thanks for listening.